In this lesson, we'll discuss how to graph lines and also review topics such as slope and the different forms of a line. You will notice there are formulas given to you. I apologize that they're a little bit fuzzy in how they appear, but I think all the key parts are there where you can identify what you need. Now, as you look at this first question, it's asking you to write the equation of the line in slope-intercept form when you have been given the information that the slope is 6 and the y-intercept is the ordered pair 0, 5. Now, your slope is always identified symbolically with the letter M. So our slope is 6, that means M would equal 6, and your y-intercept is where it is crossing the y-axis, and that's going to occur at the ordered pair 0, comma, B, because B represents that y-intercept. If we want to put this into slope-intercept form, this will be an easy task because slope-intercept form is y equals mx plus b, where the coefficient in front of the x will be the slope, represented by m, and the constant or the number that's at the end of the equation is your y-intercept, represented by b. Therefore, y equals 6x plus 5 is your equation in slope-intercept form. If you look at the next question, it asks you to find the equation when the slope is 2/5 and the line passes through the point -10, 6. Now notice this is not your y-intercept because the x part of the ordered pair is not 0, it is -10. So we're going to identify the m, the slope, as 2/5, but we don't know what the b is yet. We have a couple of options on how to find it, but probably the simplest way to find it would be to plug in not to slope-intercept form, but to what is called point-slope form of a line. And point-slope form is y minus y1 equals m times, and in parentheses you have x minus x1. And that would tell us that this ordered pair they gave us, the -10, 6, is actually going to be our x1, y1. So those will be the coordinates of the ordered pair we know. Everything else in the equation is the same as what we used before. X and y are our variables, m is our slope. So now if we plug in, we'll have y minus, and in parentheses, my y1 is 6, equals my m is 2/5 on 2, and in parentheses I'll have x minus, and I'm going to put another parentheses for the x1 because remember, I don't want to lose any signs. So anytime I'm substituting in a number, and particularly if it's following a subtraction sign, it's a good idea to put it in parentheses because notice it is a -10 that is my x1, and if I have x minus -10, I'm going to end up with x plus 10 when I clean up those signs. Minus a negative becomes plus a positive. Now, if I write this out, I have y minus 6 equals, and if I distribute on the right side, I'll have 2/5 x plus, and if I multiply 2/5 times 10 over 1, I'm going to write this over here. 5 will go into 10 2 times, and this will simplify to just become plus 4. We're really close to slope-intercept form at this moment because the only thing left to do is to move that minus 6 on the left side over to the right. And the way I do that is I add 6 to each side, and I will end up with y equals 2/5 x plus 10. And that would be my equation in slope-intercept form. Now I have another one that is very similar to what we just did. I'm given the slope and I'm given another point that's on the line. I will not show you all the steps on this, but I will tell you that y equals negative 4/5 x minus 7/5 is what you should end up with, and that would give you an opportunity to practice this on your own and make sure that you're able to get it on your own. Now, the one that follows that is a little bit different because we have two ordered pairs here. They did not give us the slope or the y-intercept because neither of these ordered pairs has an x-coordinate of 0. That means we're going to have to first find the slope and then we can plug into point-slope form. Now, the equation for finding the slope when you have been given 2 points is y2 minus y1 over x2 minus x1. Slope is the difference in the y's over the difference in the x's. You may recall from high school algebra a teacher telling you slope is always rise over run. That's because rise is the up and down, which would be your y values, over run would be horizontal, which is your x values. So we can choose either of these ordered pairs to be the x1, y1. Won't make any difference. If I call this first ordered pair x1, y1, and the second ordered pair is x2, y2. If I can get my 2's to show up a little better. We are now ready to plug in. So my y2 is a negative 2 minus my y1 is a positive 4 over my x2 is a positive 2 minus my x1 is a negative 1. Now, if you labeled these in the other order, you will still come up with the same slope. I promise. It won't matter which one you call x1, y1, which one you call x2, y2. But you do have to be very careful that when you plug in, you don't mix and match x and y coordinates from the two different ordered pairs. Here's what I mean by that. If you'll look at your formula for finding slope, you have y2 and x2 that are starting both the numerator and denominator. Okay, that means they came from the same ordered pair. So whichever y coordinate you choose to use as y2, be sure you go back and get the x coordinate from that same ordered pair when you plug in the denominator. Now, if I continue this out, negative 2 minus 4 is a negative 6 over 2 minus negative 1. That minus a negative becomes plus a positive, and 2 plus 1 is a positive 3. That means my slope is a negative 2. Okay? Now that I know the slope, I'm back to where I was on the earlier example, and I'm ready to plug in to point slope form. So if I plug into y minus y1 equals m times x minus x1, I'm going to have y minus, and if I go back and look at my ordered pairs, my y1 was 4, equals, my slope is a negative 2, and I'll have x minus, and my x1 is a negative 1. I know that's a little bit hard to see. That makes it a little better. And I know that minus a negative becomes plus a positive. So now, if I clean this up a bit, and I apologize, this is a bit cramped, I'm going to have y minus 4 equals negative 2x, and a negative 2 times a positive 1 is a negative 2. We're almost there. If I add 4 to each side, I will come up with y equals my negative 2x, and if I add 4, negative 2 plus 4 is a plus 2. You'll notice the next example, very similar to the one we just did, except actually this one is going to be a little bit easier because notice one of these ordered pairs has an x value of 0. That means when I look at this, I can see what my y-intercept is. Remember, 0b is my y-intercept, so my y-intercept is 4. Now all I have to do is find my slope, and I'll be ready to write my equation. So if I go to my slope formula, y2 minus y1 over x2 minus x1. And again, you can decide which one you want to call x1, y1 and which ordered pair you want to call x2, y2. I'm going to call this second pair that I see here my x2, y2. So I'm going to start with 0 minus, and my y1 would be 4, over, come back and get the same x that went with 0, and I have negative 1 minus 0. If I clean that up, I have a negative 4 over a negative 1, which gives me a slope of positive 4. Since I now know my m and I know my b, I can plug into y equals mx plus b, and I have y equals 4x plus 4. That would be the equation that goes with those two ordered pairs. Now, we are looking at some special kinds of lines next, a horizontal line and a vertical line. If a line is horizontal, then that means that it is crossing one of our axes, and if it's horizontal, that means it's going to cross the y-axis. So the simplest way to get the equation when it's a horizontal line is to realize if it's going to cross the y-axis, that means every point on that line is going to have the same y value. So all I need is the y value out of my ordered pair. And that tells me my equation will be y equals 7. If you were to look at the graph, and you were to plot the point negative 1, positive 7, let's say it's right here, then that would mean if it's horizontal, every point on that line has a y value of positive 7, and that's why the equation would have to be y equals 7. If you look at the next one, again, it says horizontal line. If it's horizontal, which axis will it cross? It's got to cross the y-axis. So that means our equation would be y equals -5. Now if it's vertical, vertical means that it's going up and down. And that would mean that it crosses which axis? Vertical will cross your x-axis. So you want to make sure you get those straight. That means every value on this line has the same x value, in this case x equals -4. One more vertical line question. Vertical line that passes through the point 2, -8 has to be what equation? Because it's vertical, that's an x axis that's going to be crossed, and we'll get x equals 2. So in problems 10 through 12, we're supposed to find the x-intercept and the y-intercept. Intercept simply means that's where it's crossing an axis. So if I'm looking for the point on the x-axis where this line would be graphed, if it's on the x-axis, it tells me the y value would have to be 0. So I would first, to get my x-intercept, that's going to be some value for the x, but my y value is going to be 0. So all I have to do is plug in 0 for y and solve for x. And this is y equals, and I apologize again, this did not print out very clearly. It's actually a -3x plus 3. Some of the plus and the minus ended up superimposing on top of other numbers, and it makes it hard to see. I'm sorry about that. So we have y equals -3x plus 3. And then when we plug in 0 for y, we've got 0 equals -3x plus 3. Now, I just need to move one of these terms to the left side in order to solve this. I'm going to move the -3x so that I won't have to worry about negative signs. It will make both of these terms positive. And I have 3x equals 3. Divide each side by 3, and I get x equals 1. That tells me that my x-intercept is going to be the ordered pair 1, 0. Okay? Now, to get the y-intercept, all we're going to have to do is plug in 0 for x. So my y-intercept is always the ordered pair 0, b. And if I take y equals -3x plus 3, but now I plug in 0 for x, look what I end up with. -3 times 0 is 0. 0 plus 3 is 3, and I get y equals 3. So that means that my y-intercept is the ordered pair 0, 3. Now, the next one is y equals 4/3 x minus 4. You're going to do the same thing. So if I plug in 0 for y, and I solve this, again, I can move either of these two terms to the other side. I'm going to move the one that's negative. So I'm going to add 4 to each side, and that would give me 4 equals 4/3 x, because these canceled over here. As a quick reminder, if I want to get x by itself and it's being multiplied by a fraction, you may think about dividing both sides by a fraction, but that looks funny. It's a little bit messy. You're going to have to make an adjustment anyway. Remember, dividing is the same thing as multiplying by the reciprocal. So what I want to do is to multiply each side by the reciprocal of 4/3, which would be 3/4. And as long as I'm multiplying both sides by 3/4, think of that as 3 over 4 times 4 over 1. My 4's are going to cancel, and I will get 3 equals x, because on the right side, it ends up being 1 times x, which is just x. So that tells me that my x-intercept is the ordered pair 3, 0. Now to get that y-intercept, I'm going to go back and I'm going to plug in 0 for x. And when I do that, I would have y equals 4/3 times 0 minus 4, which means I get y equals a -4, and my y-intercept is going to be the ordered pair 0, -4. And again, there's another example you can work on if you wish, but I think 2 examples probably is all you're going to need for that. Now what we're going to practice is how you would graph these lines, and since we have the intercepts, we can graph these lines pretty easily using the intercepts. Excuse me. We also were given these equations in slope-intercept form. So what I want to do is I will show you on this first equation, the y equals -3x plus 3. If I'm using slope-intercept form, this is how I can get it on the graph. I first will take my y-intercept and plot it on the graph. So it crosses the y-axis at +3. So I'm going to put a point right there. Now using my slope, which is -3, I can find additional points on this line. Now I need to pay attention to signs. Since my slope is a -3, you can think of it as a -3 over +1. Remember, you can always write a whole number as a fraction by putting it over 1. And the negative sign, remember we said, is the change in y over the change in x. So that's telling me whether I go up or down. And if it's negative, I'm going to go down. So I go down 3 and I go right 1, and that gives me a second point. I can do that as many times as I wish. If I go down 3, right 1, I'm at the ordered pair 2, -3. And now that I have these 3 points, I can draw in this line. It is much better to use a straight edge. Unfortunately, I don't really have that capability. I'm creating these on my iPad, so I would say get a straight edge when you put this on your paper. Now, I want you to notice, look right up here. We had identified our x-intercept as the ordered pair 1, 0. I know my line kind of missed it, but you can see that point there at 1, 0 is a point that's on my line, and 0, 3 is the y-intercept. So I can use either of those methods for graphing. We use slope-intercept. Now on the other line, I'm going to show you how you would graph just using intercepts. As long as I have any 2 points, I can graph a line. The only issue I have to be aware of is if I have only 2 points, I don't have any way of determining if I've made a mistake. A third point oftentimes will help show me if I have made a mistake somewhere. So using intercepts, you're only going to have at most 2 points. And if I want to plot this line, my x-intercept is 3, 0, which is going to be this point right here. My y-intercept is 0, -4, which is going to be this point right here. And now, if I draw in this line, that's what my graph will look like. We are not graphing number 12 just for the sake of time, but it's there if you want to practice. Now, we're going to look at a graph on this next slide, and then we'll see if we can come up with the equation for the line. So here's the graph, and I realize it's a little bit faint, but I think all the information we're going to need is here. If you recall, the two pieces of information we need to write an equation, if it's in slope-intercept form, would be the slope and the y-intercept. Now, if I'm looking at this graph, and I know you may find it's a little hard to read the scale, but I will point out that it does count by ones on both the x and the y-axis. And if I'm paying attention, I can see that this thing is crossing the y-axis at a positive 3. This point right here is a positive 3. Oops, sorry I made that a little high, but you get the idea. Now, to find the slope, I can choose any 2 points on this line, although I want to choose points that where it is actually crossing at a specific corner of the grids. I need to make sure that I'm not choosing something that it has a fractional value that I don't really know what it is. And then I can calculate what the slope is. So remember, slope is rise over run, or the change in y's over the change in x's. And you will see there's 2 little open circles here. Those are good points for us to use to find the slope. They just happen to be drawn in that way on this graph. They won't necessarily be open circles on other graphs. So here's what we're going to do. If I start at this lower point, I want to count how far do I have to move up until I am even horizontally with the other point that I'm trying to get to. And if I count 1, 2, 3, 4, 5, I had to go up 5. And if I'm moving up, that's a positive direction. So my rise is 5. Now my run would be going from here to here, where I stopped, over to this point that I want to get to. And if I count, I've got 1, 2, 3, 4, 5 that I'm moving, but I'm moving to the left. And if I'm moving to the left, that's a negative direction. So I have positive 5 divided by negative 5, which is a slope of negative 1. I can now write my equation by plugging back in, and I will have y equals, you can either write it as a negative 1x, or you can just make it a negative x, the 1 is not required, plus 3. That is the equation that goes with that graph. Now, in the real world, you're going to find that you don't just get equations most of the time. You have situations that you have to recognize how to solve. So we're looking at a question that says a piece of equipment used in a landfill has an original value of $100,000. After 2 years of use, the piece of equipment is valued at $75,000. So if we assume depreciation is linear, and of course depreciation is the value of the equipment that is declining as it ages, find an equation to relate the value of the equipment over time. Well, think about that for a minute. When time is 0, okay, at the very beginning, that's going to be the full value for this equipment. Typically, in the real world, if we were to consider some kind of a graph, our x-axis, which is the independent variable, most of the time ends up being time. Time is going to happen regardless, isn't it? So we're looking at how something would change over time. And notice that's what it says here. Find an equation to relate the value of the equipment over time. So we're going to have the value be our y value, time is going to be our x value. So at the very beginning, time 0, we had a value of $100,000. So you might say that our b value was $100,000. Now that's if we wanted to put this into slope-intercept form. I don't think we necessarily want to do that. Instead, I'm going to start with this beginning value, which we know is $100,000. And since this is depreciating, that means that it is going down in value. So wouldn't you think that if it's going down in value, I've got to subtract something? If you think that, you are right. The question is, what am I going to be subtracting? Well, what's involved here is how much time is passing. This value is going to change over time. So notice your question, after, or before you get to your question, it tells you after 2 years of use, the piece of equipment is valued at $75,000. So your time that's passed is 2 years, okay? What we're trying to find would be what would be the amount of depreciation that happens every year. I'm not sure what that is, but I do know that 2 years times the amount of depreciation had to equal the current value of $75,000. That's going to be the equation that you have to come up with in order to figure out what the depreciation amount is, because we're going to need to know that in order to get an equation that relates value of the equipment over time. Now, if I try to solve this, I can subtract 100,000 from each side, and I'm going to have a negative 2x equals a negative 25,000. And if I divide each side by 2, then I get x is, and actually I'm dividing by negative 2, so a negative divided by a negative would give me a positive 12,500. That would tell me what the amount of change is over time. That means I just found my slope. Okay, we already knew this was our y-intercept, our b. We now have our slope, and so we can write the value of the piece of equipment as an expression, okay? And that would be, and actually instead of y equals, since we're looking for the value, I probably should write that as v. So the value is going to equal, because depreciation is going down, it's a negative slope. So I have a negative 12,500 t, that's how much for each year the price will go down, plus my b value was 100,000. So that's the equation that we're going to start with. And if we want to know the value after 5 years, all we would have to do is plug in 5 for t. So when we do that, we'll have v equals negative 12,500 times 5 plus 100,000. And if you finish your calculations there, you're going to come up with $37,500. That would be the value that remains on that piece of equipment. Now, if I need to find how many years it would take for the value of the equipment to actually be 0, how do you think we would find that? Well, I still need this same formula. V equals negative 12,500t plus 100,000. And if I'm looking for how many years it takes for the value to be 0, what piece of information did they give me? The time or the value? Well, this time they gave me the value. I want the value to be 0, and I'm going to look for the time that would make this a true statement. So again, as long as I just need to move one of these values to the left, I can choose. I'm going to move the negative value, so that's going to turn it into positive 12,500t when it moves to the left, is equal to 100,000. So if I divide each side by 12,500, that's going to tell me how many years it takes for this piece of equipment to be fully depreciated. And if you divide that out, you'll discover in 8 years there is no value remaining on that piece of equipment.